Significant digits. The shorthand for that is sometimes sig figs, for significant figures. Okay. It's not a fruit. Okay. Now, when we were in that lab making oobleck, you were supposed to be practicing how to read the analog graduated cylinder, okay, and estimating the final digit. Now, you need to know where the meniscus is on this too. This liquid, when you put liquid in a glass container like this, the liquid tends to make a kind of a cup or bowl shape, and that's called the meniscus. You want to measure these liquids at the bottom of the meniscus. You need to look very carefully and find the bottom of the meniscus and make sure when you put your liquid in there that you're measuring the amount you want at the bottom of that meniscus. And what we said there when you were reading the amount they were using there is that, first of all, you had this meniscus, which is the curved section at the top, and you read the bottom of the meniscus. But then you estimate the last digit. That is to say, whatever markings you have on that graduated cylinder, you're going to estimate where the bottom of that meniscus is between those markings. And if it's dead on those markings, you're going to add a 0 to that. So if you're dead on, say, 18, that would not be 18. It would be 18.0 milliliters of green liquid. Or if it's slightly over that, it might be 18.2 milliliters. Or slightly less than that, it might be 17.8 milliliters. Okay? But you're estimating the last digit regardless. So that last digit, then, is always going to be estimated or uncertain. Okay? Now, that doesn't matter. It doesn't matter whether or not you're using an analog device like a graduated cylinder or like a meter stick. Even a digital device like the balance we used, that last digit is always uncertain. Now, if I have two measurements then that say have 3 or 4 digits, and I divide one by the other, that's going to give me a whole bunch of digits sometimes, okay, if it doesn't round off properly or round off evenly. And so how many of those digits do we keep, and how many of those are really real or make any difference? And that's what significant digits is about. So the rules for significant digits take into account what digits are not really known. Okay? So let's say we're going to add some digits together. And there's 2 separate rules. Actually, there's more than 2 rules. We're only going to learn 2 rules in here. And the rules we're going to use are going to be somewhat simplified. When you get to college, you may learn a more complete way of rounding off and handling significant digits than we're going to do in here. We're going to try to keep it reasonably simple with only 2 rules. One rule is for adding and subtracting, and the other rule is for multiplication and division. Okay? So we're going to start with adding and subtracting. Let's say we're going to add, say, 3 measurements together. Suppose I have 14.78 grams of, I don't know, table salt. Okay? I'm going to add that to 101.3 grams of table salt. And I'm going to add that to 3.761 grams of table salt. Okay? So I'm adding all these together. Okay, I get 119.841. Notice I didn't put any zeros here. Okay, I know that when you were in elementary school, your teacher told you to put more zeros so everything lines up neat, right? Did she not, or he not? Yeah? Okay. Well, we're not going to do that anymore. Okay? That was kind of a thing you did to try and make the addition and subtraction easier. We're not going to do that anymore. Not in here. And the reason we're not going to put any more digits on there, if you remember from the lab, you estimated whatever that last digit was. And there aren't any digits afterwards. Okay? To put zeros over here to get everything to line up nice and neat would be lying about how precise the measurement was. Does that make sense? That number with extra zeros would not be a true representation of what was measured anymore. And so we can't put zeros on there. We shouldn't put zeros on there because in the sciences, if you're saying something that is going to be clearly interpreted incorrectly from what you meant, you're basically lying. Okay, so you don't want to mislead people. That's lying. Okay, we want to be ethical as scientists. All right, so we don't put zeros over there. So if you'd like to have something to help you keep up with the placement of all the digits, use an arrow, but not a 0. Okay? Arrows are fine, zeros are not. Not if you're adding on there for a placekeeper. Okay? Does that make sense? All right, what that helps you do is to figure out how many digits are significant. Because if you're adding this 1 to two numbers that, oh, we don't know what those are, we don't really know what that should have been. Maybe those are numbers that would make this a 9. We don't know what that is. So that number is insignificant. This 6 and this 8 added together making a 14, it might have been a 19. It might be a 25. We don't know what it was. And so neither one of these digits are significant. So when you add digits or subtract digits from an empty slot, when you add digits or subtract digits from an empty slot to the right, okay, not to the left, we don't worry about those over here. When we add digits or subtract digits from an empty slot, those digits, or the digits in the answer that result, are insignificant. The digits in the answer that result are insignificant. And we show they're insignificant by underlining them. So when I write it down like this, I'm saying this digit, this 4, and this digit, this 1, both of these are insignificant. Okay, they really don't matter because you know what? We don't know what they would have been if we'd known what digits fit in here. If these two measurements have been measured to a greater degree of precision. Okay? Now, I sort of highlighted that word precision when I said that because we're going to learn about precision and accuracy in this unit as well. Okay? All right, so those digits are insignificant. What we're going to do is round those off. Now, the way we're going to round it off is we're going to have an operator. When I say an operator, this plus sign, that's an operator. An equal sign, that's an operator. It's a mathematical operator. It tells you what operation you're performing. Okay? The operator for rounding off is an arrow. It doesn't have to be a curved arrow. It could be a straight arrow. Okay? But it's an arrow going from this number to what I'm going to round it off to. So I'm going to round it off to 119.8. And that's grams of NaCl. Okay? That's my final answer. Well, this is also grams of NaCl. It's just unrounded. I'm going to keep my units and digits there. Now, it's important that whenever you write down a number, you tell me what that number applies to. Okay? You can't just write down a number. Let me give you an example. How many of you would like to have 100? Oh, y'all not raising your hand because you're. Oh, she's raising her hand. Okay, she's raising her hand. But they're kind of being careful about it. They're barely raising their hand. Okay, because they know something's coming, right? How about 100 kicks upside the head? Oh, you don't want that. Okay, so see, you didn't know what I was talking about when I said you want 100, right? You're used to hearing 100 and thinking that's a grade. That's a percentage grade. Yes, right? But you didn't know that. You made an inference, didn't you? Right? We talked about inferences the last couple of days. So we don't want to do inferences here. We don't want to make assumptions here. We want to make sure we're clear. Okay? So if it's grams, you're going to write grams. If it's grams of NaCl, you're going to write grams of NaCl. Got that? Always units and species, if both of them apply, are written with the number. Otherwise, the number is useless. And that's especially important when you're doing things in the lab and you're making measurements. It's not enough to write down the mass in your lab notebook. You've got to say with mass of what? Okay? Because you'll be weighing a lot of different things back there. If you don't keep up with which one is which, you won't know what to add or subtract to get the answer you need. So you've got to be very careful about how you write these things down. Any questions about that? Yeah. Oh, I'm sorry. I put the decimal in the wrong place, didn't I? Just don't do that. Got to watch out for that. Put the decimal in the right place. That was just me not paying attention. Not good. Thank you for catching it. Okay? All right. All right. Any questions about that? All right. So the same thing applies to subtraction. The same rule for addition and subtraction applies to subtraction. So I'm going to give you a problem that you solve it. Okay? Okay, if a beaker contains 12.5 milliliters of acetone and 2.751 milliliters are removed, how much acetone remains? That's your problem. Okay, let me do this problem with you and let's see how you did. Compare what you did to what I'm going to do. So we've got 12.5 milliliters of acetone. We're going to remove 2.751 milliliters. So 12.5 milliliters. Probably didn't leave enough room there. Acetone. And 2.751 milliliters of acetone. Now those arrows are not required. they're optional. If you want to leave the arrows off, that's fine. I usually put them on here just to illustrate the fact that I have empty slots. Okay. Now you have to have the unrounded answer. It's required that you show me the unrounded answer, but then you're going to show me all the rounding as well. That's part of showing all your work. And showing all your work is probably more important in here than actually getting the correct answer. So now we're going to round that off to 9.7 milliliters. Is that what you guys got? Did okay? All right, so that doesn't seem too hard, does it? Now, it would be helpful to me, if I'm grading your paper, if you were to put a box around your final answer, because it just helps me to find it in a hurry. Okay, and also, if you're not the neatest writer in the world, if there's a bunch of numbers on there and I'm trying to figure out which one's which, it helps me to find it, find the right one and not give you the wrong grade. Okay? And we'll get to really complex calculations in here that, you know, it's really important for me to know which one I'm looking for. All right, any questions about that? All right, then. So that's the rule for addition and subtraction. Did everybody get the right answer? You do okay? I don't see anybody shaking their head no. No questions? All right, then. Now, that's the rule for addition and subtraction. Okay, to repeat, anytime you're adding or subtracting numbers, if you have any digits that result from an empty slot on the right, you're going to round those off. Okay, those are insignificant digits. The ones you're rounding off are insignificant. That means that any digits remaining, by the way, are significant. Okay, so the significant digits in this answer are the ones that remain after you round off. Okay, it still makes this digit, this is still an estimated, this last digit's estimated. Okay, because that one was estimated. Okay, so the last digit's always going to be estimated or uncertain. Okay, so you got insignificant digits and you got significant digits. Once you do all the rounding off, what remains are the significant digits. Any questions about that? So there's a different rule for multiplication and division. We'll attack that one tomorrow, okay? So tonight, what are you going to do? Post lab, study for the test, okay?